Hello, ladies and gentlemen. Today we are going to talk about 10.2, which is about congruent chords. The good thing about this section is there's really only one new concept in it, and it's a pretty simple one. A lot of today's work is just algebra work, trying to find quantities using algebra. We have two theorems, but the two theorems that we have today are actually sort of the same theorem, flipped on its head. So we have one theorem, and then we have the converse of the same theorem that means the same thing. So the first one says if two chords are equidistant from the center of a circle, then they are congruent. And this is a formula that should, or a theorem that should make sense kind of intuitively. If you look down here at this circle, we have two chords, and if these two chords are the same distance from the circle, then they must be the same length. Since we measure distance on a perpendicular, there's no way that the chord could be like tilted more or less to be longer or shorter. It has to be the same length if the distance is the same. So 2 is the converse of that. It says if two chords of a circle are congruent, then they are equidistant from the center. Right, so if we know the chords are the same length, then we also know that the distance from the center between those to the two chords are the same. So what can we do with this information? Well, we can do a couple of different things. So we can write equations for the most part. We always have a whole bunch of given information for these types of problems that we should probably put into our diagrams. So we're given circle with center O, and AB is congruent to CD. So AB and CD are our chords. Since I can't really put my normal congruency markings on here because they'd get buried, I'm going to put the little arrow congruency markings. And then it says OP is 12x minus 5. So that's going to be OP is 12x minus 5. And OQ is 4x plus 19. Find OP. Well, since I know that the chords are congruent, then by the theorem up top, I also know that the distances to the chords are congruent. So OP and OQ have to be the same distance. So I can say 12x minus 5 equals 4x plus 19. I'm so sorry about the jiggly camera, guys. I'm trying everything to stabilize it, but my camera is just attached to the table that I write my notes on, so it's kind of jiggly. So here I'm going to solve this. I'm going to subtract 4x from each side, add 5 to each side. I get 8x equals 24, divide by 8, and x equals 3. So 3 is not the answer, 3 is just x. In order to get OP, I need to plug 3 in. So 12 times 3 minus 5 is 36 minus 5, which is 31. So OP is equal to 31. So the next one is kind of a similar problem. It just has some different starting information. In circle O, OP is congruent to OQ. So we can mark those two congruent, and we can say, oh, since I have congruent distances to those chords, I must have congruent chords. So if PA equals 2x minus 2, notice that PA is only half that chord. And CD, the whole chord over here, equals negative 3x plus 38. Find BP. So we want to find the other half of this chord. We know the chords are congruent. They must be because they're the same distance from the center. So what we're going to do is we're going to set them equal to each other. But we only know half this chord, so we're going to need to double it. So 2 times 2x minus 2 is going to be the same distance as negative 3x plus 38. So equals negative 3x plus 38. So that gives us 4x minus 4 equals negative 3x plus 38. Add 3x to both sides. Add 4 to both sides. And we get 7x equals 42. Divide both sides by 7. And we get x equals 6. And once again, that's not our answer. We need to take that 6 and we need to plug it in. Since we're looking for PB, we want to find that distance, which is the same as AP. So we know it's 2x minus 2. So 2 times 6 minus 2 is 10, which means that PB or BP is 10. Right, the next problem goes a little bit a little bit longer, but just a little, not anything crazy. So in the circle at right, AB equals 9x plus 1. So AB equals 9x plus 1. CQ equals negative 7 plus 12x. And PO equals QO equals 2. So both of these are equal to 2. What is the radius of circle O? Well, since we know the distance to the chords is the same, we know that the chords are congruent, and I can set these two chords equal to one another. But I also see I have another instance where I'm only given half the chord. So I'm going to need to double this quantity to make it equal to 9x plus 1. So 9x plus 1 equals 2 times negative 7 plus 12x. All right, so that's going to be 9x plus 1 equals negative 14 plus 24x, and then we will subtract 9x from each side, and I get 1 equals negative 14 plus 15x. Add 14 to each side. I get 15 equals 15x. All right, divide both sides by 15. And I get 1 equals x, so x is 1. But keep in mind, I want to find the radius of circle O. So to get the radius, I'm going to think about what we did on the last day that we had notes, so in 10.1. Because in 10.1, we found out how to find the radius of a circle. And we did that by finding that right triangle. So I'm going to plug 1 into negative 7 plus 12x. So negative 7 plus 12 times 1 gives you 5. So CQ, the distance CQ is equal to 5. So what I've really done here is I've created a right triangle with side lengths 2 and 5 and x, and that x is the radius of the circle. So I'm going to say 2 squared plus 5 squared equals x squared, and that's going to be 4 plus 25 equals x squared, so 29 equals x squared. Take the square root of both sides, and you get the square root of 29 equals the radius x. All right. Notice how you can go further with this. So if you wanted to, you could find the area of the circle now that you know the radius, or you could find the circumference of the circle. You could find lots of things out to go further with this. So we don't need to stop at radius. We just did because the problem asked us to stop at radius. On the back there are 2 practice together problems. Pause the video here and try those practice together problems, and I will show you the answers to those. So go ahead and pause. All right, here are the answers. The length of EF is 6, and the length of the circumference is 12 root 2 pi. All right, and if you need any longer to look at those, you can just pause this video and keep looking. All right, so go ahead and do the 10.2 worksheet. Thank you very much.